Hello students, this is Srinivas from Inside Physics channel. Today we will discuss one topic in fluid dynamics. See, in fluid dynamics, the variation of pressure in a fluid while the fluid is moving in a vertical direction with some acceleration. So here we will calculate the variation of pressure between 2 points while the liquid is in acceleration vertically. So pressure difference in a fluid moving with acceleration, right? See, actually, in fluid, the pressure difference is of so much importance in due course. So here, for that, to calculate the pressure difference, we will take a beaker having a fluid of density rho. So in this fluid, there will be an imaginary 2 points which we take it as P and Q. So here we will calculate the pressure difference between the point P and the point Q when the fluid is moving vertically with some acceleration. In first case, vertically upwards; in second case, vertically downwards. For this, we imagine a cylindrical structure where the point P is on the upper surface of the cylinder and the point P is on the Q is on the lower surface of the cylinder. The height difference between these 2 points will be h. So there are apart with a distance of h. Now consider that the liquid is moving vertically upwards with some acceleration. In this case, what will be the pressure difference between these 2 points? So you know the motion of a fluid in fluid mechanics is very important. So here first the force on the point P. What is the force acting at the point P? We know that area of cross section of the upper surface and the lower surface is A. Both surfaces have an equal surface area A. So the force acting at P, we know this is P1A. Apart from this force, what is the other force that can act on the surface and this entire surface will be plus mass of the fluid contained in this cylinder. So next, the force acting on the point Q. So this force will be in upward direction and this force will be in downward direction. So the force acting on the surface will be in this direction and the force acting on this point will be in this direction. Why we have taken this imaginary cylinder means we cannot calculate the force or pressure at a point. So we need to consider a surface area, and the surface area is having some pressure or force on upper and lower surfaces because of the fluid movement, right? So next, the force acting at this point Q will be F2 is equal to P2A. A is the area of cross section of the lower surface. Now imagine that the fluid is moving vertically upwards with some acceleration A. So to move an object with some acceleration A, there should be some net force acting on that element, right? So the net force acting, we can take it as F2 minus F1 is equal to ma, right? A is acceleration with which the fluid is moving. See, mass of the fluid is m. Here, if we substitute what is F2, P2A minus F1 is P1A plus mg is equal to ma, right? Further, P2A minus P1A minus mg is equal to ma. Here we know what is mass. Mass is equal to volume into density. We know that mass is equal to volume into density. See, by this we can write what is mass? Volume into density into gravity is equal to same. Volume into density into acceleration. Here, look at this. P1A minus what is volume? Volume of the cylinder. Area of cross section into height is volume, right? Area of cross section into height is volume. So density of the fluid we already know rho, and gravity is g. Here also A h, volume is equal to area into height into density rho and acceleration with which the fluid is moving. So this is the equation. From this we can take the area of cross section as a common factor and we can delete on both sides. So by this we can write is equal to P2 minus P1. So here H rho A plus H rho Z, right? See, we have arrived at the pressure difference. See, I have taken one step as directly. The A common on both sides I have deleted. Okay. P2 minus P1 is equal to H rho A plus H rho Z. Further we can write, if we take H rho as common factor, we can write it as A plus Z. This is the pressure difference between 2 points in a fluid which is moving with acceleration vertically upwards. Similarly, we can derive when the fluid is moving downwards. Similarly, we can derive when the fluid is moving downwards. That equation will look like P2 minus P1 is equal to H rho into A minus Z. Right. So, in two cases, we have seen that pressure difference will be H rho into A plus G, H rho into A minus G. This is how we should calculate the pressure difference while the fluid is moving in vertical direction. So here, when the surfaces are at a height h1 and h2, we know that the pressure acting will be H rho g and P2 is equal to H2 rho g. See, when the P1 and P2 are at a heights h1 and h2 from the surface, we know that the pressure acting on the points will be h1 rho g, h2 rho g. So here the average pressure acting on the entire cylindrical surface, we can take it as, see, the average pressure will be P average is equal to P1 plus P2 by 2. So in this case, how it look like? Rho g into H1 plus H2 by 2. Okay, this is the average pressure acting on the entire cylindrical area. And if you take force from this pressure, force acting on this cylindrical area, we can write P average into area of cross section, right? Force P average into area of cross section. So this is the average force acting on the entire surface. So this is how we go through the pressure variations in fluid mechanics or fluid dynamics. So in next class we will see some more topics in fluid dynamics.